All right, assignment 5-6. Question number 1. These are called diffie-Qs. That's kind of the cute name for them. Or differential equations. And let's just go through the steps right now. And so for problems 1 through 4, find a general solution. And then for y, in problems 2 and 4, it says solve for y. All right, here we go. So y prime is dy by dx. Now here's the key, the big part of the lesson, honestly. Separate the variables. So we want x's on one side and y's on the other side. So I'm going to multiply by 2y squared plus 3, and I'm going to multiply by dx. So I multiply by dx, I multiply by this. Now, do you see? The y's are on one side, the x's are on the other side. And now I integrate. So the integration here, you add 1 to the exponent and divide. That's 3y. On the other side is x's. That's x cubed divided by 3. That's x. And then don't forget the candy at the end. It said don't solve for y. That's what it said. Only for problems 2 and 4. Number 2. Notice we already have dy by dx. So a good step is to multiply by dx to begin with. So I'm going to multiply by dx. 1 times dx. The dx is cross out. So there we go. And then I want to separate this. So I'm going to divide by e to the x. I'm going to make that calculus friendly in a second. So I'm going to divide by e to the x. And then I'm going to make it calculus friendly. So I'm going to write that as e to the negative x dx. That way I can apply rules to it. So now I'm going to integrate both sides. The integration of y is y squared divided by 2. The integration of e to the negative x. Well, the hook is negative 1, so I need a negative in front. Other than that, it's negative and copy. And then plus c. To get y by itself, do we have a point for number 2? No. All right, so to get y by itself, multiply everything times 2. And then square root. Now when you square root, the answer could be positive or negative. That's going to be an important point eventually. But for right now, that's a great way to answer it. All right, number 3. Just to know that we're just beginning this topic of differential equations in terms of calculus, that when you go to university, you could have a whole course on this. This could take months just on this topic. And then you'd say that the class that you're taking are diffie-Qs. And so a whole class could be on differential equations. So we're just beginning to understand what it is. So ultimately, a differential equation is a derivative equation that we're solving. And there's applications that go with it. Step 1, change that to dx by dy. You know that you should only watch this until you need it. And then when you want to try the next step, press pause. So how did I write this? dy by dx. All right, so multiply by dx. And then I need to separate the variables. So I'm going to divide by 2x and divide by y plus 1. And then I'm going to integrate both sides. So the derivative of y plus 1 is 1. This is a logarithm. The derivative of 2x is 2, so I need a 1/2. So it's a logarithm, but with a 1/2. And then plus c. At this step, I want to solve for y. It's a logarithm, so I'm going to write it exponentially. So what's inside the logarithm is y plus 1. And then the base for ln is e, and then this goes in the exponent. Now, I already know this exponent will make that the square root of 2x. The square root of something already is positive, so we can just leave it as the square root of 2x. Oh, for number 3, it said don't even try to solve it, right? I'm not even following the rules. So in number 3, leave it just right like that. I was just looking at the answer key. Number 4, this one I'm going to solve for y. There's a certain structure and pattern as you're solving a diffie-q that the more you practice, you'll get comfortable with. Step number 1, it's dy by dx. Step number 2, multiply both sides by dx. This tells you where dx is going, or the y's are going, and this tells you where the x's are going. So wherever dy is, that's where the y's are going. So I'm going to divide by 2y. In fact, I don't even need to do that. I could just divide by y to make it a little bit easier. So divide by y, keep the 2 there, and then divide by x minus 2. It just makes it, I'm trying to get y by itself, so I'm trying not to be too complicated about it. You could divide by 2y and get the same answer at the end. Integrate this. The derivative of y is 1. This is a logarithm. Don't forget the absolute value bars. The derivative of this is 1. And what it was before and what it became, it needs a 2. So it's 2 and that logarithm. And now I'm going to solve for y. So to solve for y in this case, we're going to write it exponentially. So it's inside the logarithm. This ln, the base of it is e. Notice this becomes the exponent. So as soon as we square it, we don't need the absolute value bars because it's automatically always positive. And then I'm going to write it like this, times e to the c. Now, in exponent rule, when you multiply and the bases are the same, you're adding. I'm just writing it differently. I can then redefine this as a separate constant to make it easier to work with. So I'm going to take this constant, e to the c is just a number, and I'm making it I'm redefining it to make it easier to work with algebraically. And you recognize that e and ln, they cross out, and you're just left with x minus 2 squared. I think that's it. And we have our answer. And by the way, if we want to remove the absolute value bars, this would be plus or minus. And so that plus or minus constant, whether it's positive or negative, it's just a constant. I can then remove the bars and just make it equal to that. Number 5. All right, I want to solve this diffie-q. So I'm going to multiply both sides by dx. And then it tells me the y's should be on the left and the x's should be on the right. So I'm going to multiply by y. And now I'm going to integrate. So when I integrate y, you add 1 to the exponent and divide. Here, I'm going to add 1 to the exponent. When I divide, the 2's cross out, and it's just x squared. Now, the derivative of negative x squared is negative 2x. See how they match? And then plus c. At any point, you can plug in. So what I'm going to do right now is I'm going to multiply everything times 2. I can redefine this to make it easier and just call it a new constant. It's a good practice to get into. And then I'm going to plug in. So I have a point to plug in, which is 2, 4. So I'm going to plug in the y coordinate, the x coordinate, and now I'm going to solve for the constant. So we have 16 This is what? 4 times negative 2. I hope that's negative 8. So when I solve for the constant, add 8, I get 24. And now I go back to the equation. So I go back to this equation, y squared equals negative 2x squared. And then I put in 24. Then I'm going to solve for y. So I'm going to square root. Now, normally the answer would be positive or negative. Now, the key here is the y coordinate of the point you're given. So the y coordinate you're given is a positive number. Therefore, this will be positive in front. If the y coordinate was a negative number, then you'd be negative. But you don't put down plus and negative when you're given an actual point. If you don't have a point and you're writing the answer generally, then you need positive or negative. But if you're given a point, then there's just one answer. It's either positive or it's negative. And how do I know? Is by checking at the y coordinate of the point that's given. And there's your answer. All right, number 6. All right, let's see. Can you press pause and try to separate the variables? So I'm going to multiply by dx. I'm going to change this. So the y's are on the one side and the x's are on the other side. Then I'm going to get, so I'm going to divide by y and divide by 3x. So I divided by 3x and I divided by y. I kept the negative here because I just want to get y by itself. And now I'm going to integrate both sides. On an AP exam, the ability to separate the variables gives you a point. The ability to integrate, like I understand that's a logarithm, that's a point. Here, the derivative of 3x is positive 3. What it was over what it became is negative 1/3. So it was negative 1, it became 3. Then you can do the logarithm of the denominator. I'm going to write this exponentially. So we have y, e, because that's the base for the ln, and then all this goes in the numerator. Now, I know a property of logarithm, that becomes the exponent. And instead of plus c, I'm going to write it as times e to the c. They're the same, but now I can make this plus or minus and now I can replace it with an easier constant. So it could be positive or negative, e to the c. Instead, it's just going to be one constant, redefined. I'm going to call it C2. And then I'm going to substitute the point that I'm given, which was 1e. So that means the y value is e. Oh, what happens here again for e and ln? What happens? They cross out and you're just left with 3x to the negative 1/3. So there's a property where e and ln cross out. That's what you're left with. E, this is 1. So I have 3 to the exponent negative 1/3. So the constant then is e divided by that. Right? Yeah. That's what it is. So the whole equation then, we go back to here. Nope, back to here. So we write y equals, we now know this is e over that. That's the constant. And then we have 3x just like that. What did I do? Did I make it 3x and it was just x? Did I write the question wrong from the beginning? No, there's a 3 at the beginning. That's fine. All right, there's your answer. All right, number 7. Already wrote in the back of this. All right. For number 7, find an equation of a function that contains the point negative 2, 1, and whose slope, that means the derivative, is x over 2y. So when it says the word slope, that means slope. We're going to solve this diffie-q. So what do we do first? Multiply both sides by dx. What do I do next? Multiply both sides by 2y. And then I'm going to integrate. So the integration of 2y, you add 1 to the exponent and divide, that's y squared. The integration of x, we add and then do that. Add 1 to the exponent and divide by it, and then plus c. At this step, I'm going to plug in the point. So we have negative 2 and 1. So I'm going to plug 1 in for y. I'm going to plug negative 2 in for x, and then I'm going to solve for c. So 1 squared is 1. 4 divided by 2, easy peasy. Subtract 2. C is equal to negative 1. Come back here to this step and put in what c is. And then the last step is I'm going to square root. And it just said find an equation. So if I square root this, because the y coordinate is positive, that's the answer. It would be negative if the y value was negative. Done. Number 8. See if I have any paper left that's not graphing paper. Some are here. There's some. All right, number 8. Do you try to press pause and do it first? $1,000 is placed in a certificate of deposit in which interest is compounded continuously. This is the formula for compounded continuously. This is the formula for compounded continuously. And $1,000 is placed, so we have $1,000. The interest rate, 5.5%. So 5.5 as a decimal is 0.055. So think of 5.5% and move the decimal 2 to the left. That's where that comes from. And then the time. How much would it be worth in 1 year? That's part A. Use your calculator. It'd be 1,056 and 54 cents. Plug in for 5 years. So plug in 5. That's $1,316.53. Use your calculator. This is all part A, isn't it? 1,000 e to the 0.055, and now the year is 10 years. So keep replacing t with what these numbers are, and that's $1,733.25. All right, part B. What time would it take for it to be worth $1,200? So there's your equation. Make it equal to 1,200. Solve for t. Use your calculator. Go comma t. And t would be equaling to 3.315. For part C, the time it would take to double in value. So for this to be doubled, it would be 2,000. And again, use your calculator. Go comma T when you solve it. And then time there would equal 12 years. No, 12.603 years. Number 9. Suppose 200 bacteria are introduced into a culture to study their rate of growth. 2 days later, the culture is found to contain 300 bacteria. Assuming the rate of growth is that PERT, or you can write it like this, that's the same formula. How many bacteria will be present in 3 more days, or 5 days after the start? So we started with 200. 2 days later, it's now 300. And so, 2 days later, that's a 2, right? All right, solve this, go comma K with your calculator and find the rate. So just solve that with the calculator, comma K, and you get about 0.2027. Next, it says, now that you know the rate, which is 0.2027, it says now how much will be present in 3 more days, or 5 days after the original amount. So type that into your calculator, and the answer is about 5. Now this one you do have to round to a whole number, because you can't have a decimal amount of bacteria. So the answer would be about 551 bacteria. Number 10. Find the half-life. Now, one of the ways to find half-life is there's actually an exponential equation for that. And the exponential equation is this. How much did you start with? Which is 4.92. No, find the half-life of a radioisotope if 4.92 grams out of initial 5 grams. So let's try that again. So initially you had 5 grams. And it's 1 minus 0.5. It's half-life. And what I'm trying to solve for how much will remain after 10 years? Find the half-life if 4.92 grams out of it remain after 10 years. Okay. So this is what remains. That equation is going to solve for the half-life. And if you do that, I think it's 429. Let me just double check to make sure. I could have just totally done something wrong. It can happen. I did it right. Who knew? Who knew? And there's the setup and the answer. Number 11. An isotope, sounds fancy, is used for estimating how long certain living organisms were on Earth. The half-life, so we're going to use this again, is approximately 5,730 years. If the skull of an ancient primate contains 10% of its original, imagine how long ago the primate lived. So, only 10%, that's 0.1, and half-life, and the half-life is 5,730. So every 5,730, it becomes half its size. We're going to solve this equation. All right, menu algebra solve. Let's do it with me. See if I get the right answer. 0.1 equals comma t at the end. I get 19,034. Where's my answer key? Look at that. To the nearest thousand, 19,000. Are you kidding me? That's good math right there. Do you know there's other ways to solve it that would take up half a page? That's pretty good right there. Number 12. We did some of this work back in compacted math, in Math 3, talking about half-life. So if you have that book, doing that, you can go back to it. 12. A worker at a hazardous waste plant, this is a big story, is accidentally exposed to toxic chemicals. Upon feeling ill, the worker went to a hospital, had some blood drawn. This is a full story. The concentration of chemical in the blood drawn was found to be 0.0158 milligrams per milliliter. Expensive medication, not the cheap stuff, was administered to counter the effects of the chemical in the blood, but the doctor on duty knew that the concentration of the chemical in the bloodstream would have to decrease gradually over time based on this model. So we know that right now, this is what C is. So medication would have to be administered every hour until the concentration was below 0.0050. 2 hours later, the blood was drawn again, and it was found to have a chemical concentration of 0.0126. That's 2 hours later. So use your calculator and solve for K. So there's your equation for number 12. It is going to be a negative number. So if you use your calculator, you get approximately that. So now we know the rate. Now we need to know the time. So it says write the particular solution for the exponential decay of the chemical in the blood. So that's what this is. Part A, 0.0158. E to the negative 0.3, that's the particular one, that's A. B, sketch a graph of that. Jeez Louise. So if you sketch a graph of that, if you plug in 0 for T, you're going to start at 0.0158. And it decreases. There it is. That's B. C, find out how long it'll be before the patient can take off the medication. So that's when the blood amount is at 0.0050. That's in the story. Again, we're going to let the calculator do the hard work. We're just going to set it up. So how long until it becomes this amount? So type that in, comma T, and solve it. Press pause and see if you get the same answer as me. 10.168 hours. So just over 10 hours, it's going to go down to that amount. Part D, when the patient has only a negligible amount of chemical, less than 0.0001, it can be released. How long until the patient has to be hospitalized? So again, we're going to make it equal to 0.0001 and let the calculator do the hard work here. So type this in, comma T, and solve it. Press pause, see if you get the same answer as I do. It's a lot of hours. That's 44.740, so almost 45 hours. That's almost 2 days. That's a lot. E, occasionally patients exposed to the chemical suffer damage to their nerves. That's awesome. Awful. I don't know why I said awesome. Awful. A maximum concentration of 0.02 requires a follow-up examination. The doctor estimated that the maximum concentration of the chemical in the worker's bloodstream occurred 1 hour before exposure. So the patient estimated 1 hour after the exposure had been about 3 hours to his blood being drawn for the first time. Should the patient be asked to return for a follow-up, yes or no? So this is part E. So 3 hours before means it's going to be -3. So I'm going to use this equation, and I'm going to put in -3 because it's 3 hours before. So 0.0158, all of that good stuff, -3 because it's 3 hours before. And I want to know, so you can go forward in time once you have a model, but then you can go back in time too once you have a model. And what was in his bloodstream 3 hours before he got to the hospital? Do you see why, when you work in medicine, that being good at math matters? Just like it matters to care for the people you care for. But if your math is poor, it's hard to care for them the same way, right? Like, we want good math so we can get good care. Anyway, there's my little rant. I like it if I go to the hospital and the nurse knows I'm a math teacher and they say, I love math in school, then I feel like really confident in terms of what's happening. If a nurse says that was my worst topic at school, then I get nervous. But, you know, hopefully all's the best after that. Anyway, what's the answer there? And the answer is 0.022 is the answer. So 0.022 means it needs a follow-up. So we need to return. That's too high. So the patient definitely needs to return, right? Due to that number. And then it says find the half-life of this. I'll do that up here. So to find the half-life, how long it takes to become half the size. Oh, here. So ultimately, half-life, this is what you're solving for. So when will it become half its size? At what time will it become half its size? So take that equation, comma t, and you get the answer about 6 hours. Wow, what a great question that connects calculus to the medical field. You're welcome. Look at all that good stuff. I feel like a doctor writing all this stuff out. That's about as clear as a doctor's note, right? Huh. All right, number 13. All right, that was like the, wow, that was some good stuff. Now it gets a lot easier. So this is all review work, working with logarithms. Could you simplify this? This is because the bases are the same. You can subtract the exponents, and ln and e undo each other. So we're just got e squared. Oopsie. Try that again. The base is the same, so it's just 2 minus root x, and then they cross out, and there it is. Number 14. Do you know your logarithms? So when you're subtracting, you divide, and then it reduces to a over b. Number 15. Do you know your differential rules? Let's see. This is the product rule. That's the first times the derivative of the second plus the second times the derivative of the first, which means we copy it, the derivative of the exponent, and then it needs a ln 3 at the end. Number 16. f at y, e to the square root of y squared. Can you take the derivative here using the quotient rule? That's the bottom times the derivative of the top. So you copy it. Square root of y would be 1/2 y to the negative 1/2. Subtract the top times the derivative of the bottom, and then the bottom squared. Next, 17. The derivative here, the product rule, the first times the derivative of the second times the derivative of the first. Done. 18. Anti-differentiation. So I got to go the other way. I got to integrate this. So a good place to start, write it calculus friendly. Actually, don't even do that. I just think, take the derivative of the denominator. So the derivative of the denominator is 0, copy it, and then negative 1. Compare, it needs a negative in front, and now they match. So it's just a logarithm. And don't forget the candy bars when you do a logarithm. Number 20. This will be the last one. No, number 19. 20 will be my last one for this video. So number 19. So these power terms are like terms, so I have to divide. Now, because it's a monomial, I can just go 2x divided by x and 4 over x. And then do the antiderivative of that. So the antiderivative of 2 is 2x. For 4 over x, this is going to be a logarithm with a 4 in front. Number 20. We get stronger by practicing correctly and not giving up. We're going to integrate this. Whenever I'm integrating a logarithm, I look for 1 over t, which I see. So I see 1 over t. And that's the hook. So the hook is there. So I just have to do the power rule, which means I add 1 to the exponent and divide, and then the, oh, that's it, plus c, right? Done. All right, Mr. G Math, I'm proud of you. We're almost done our work. Till next time.